Good morning. So we're going to start a new unit that is very similar to kind of what we left off on, and this is the new chapter. It's chapter 6, linear functions. So that should ring a bell. Our last one we looked at linear functions and how they kind of have a rate of change, and that's what we're going to be looking at right now, is that rate of change that we have already looked at. Okay, but we're going to practice them and get really good at them, because that's one of the most important things that you will have to learn in math. Alright, so we've already done this. Rate of change is the change in the dependent variable over the change in the independent variable. That I would not remember, though. I would not worry so much about that. This is the better way to put it. Change in y over change in x. Because if you remember, change in y is the dependent and the x is the independent. So that makes sense. So it's change in y over the change in x. Okay. The change in y is called the rise. Okay. The change in y is called the rise. How much does it rise up? Okay. If it's a positive number, it's rising up. If it's a negative number, it's rising down. Or I guess falling would make more sense. The next one is the change in x, and this means the run, which means how much sideways are you going. Okay, positive means to the right, negative means to the left. So if I drew a little thing here, for run, positive means to the right, negative means to the left. For rise, positive means up, and you guessed it, negative means down. Okay, so this is the equation for it, our slope, or our slope means rate of change. So our slope is our rise over our run. Okay, so if you look at this example, we have a line which is a dot here and a dot here, and it's connected. Okay, so 2 points and they're connected. This point is -3, -2. This point is 3, 3. Okay, so we need to know how much do we rise to get from here to here, just in the y aspect. So to do that, you can draw a straight triangle, kind of. It would have to be a right angle triangle, though, kind of like the trig ones we were working with. So our rise is the change in y, and this goes up 1 square, 2 squares, 3 squares, 4 squares, 5 squares. So our rise is 5. And then here our run, or our change in our x variable, is how much in the x direction do we change to get from here to here. Okay, so we went up to get from here to here. Now if we go right, we can go right 1, 2, 3, 4, 5, 6, and that matches up with that dot. So we go right 6. Now we look, is it positive numbers or negative? Our rise went up, and if we remember, up was positive, so it's +5, and our run was to the right. Okay, so that's also positive. Okay, so our rise is 5 and our run is 6. So if I want to complete this equation, our rise is 5 and our run is 6. So that means my slope is 5 over 6. Okay, and what that means is you're rising up 5 units for every 6 units to the right that you go. Okay, another way to look at it is every time you move over once, you go up 5/6 of a box. Okay, every time you move once, you only go up 5/6. Okay, so two ways to represent it. Or you go up 5 when you go over 6. Okay, they would both get you the same slope. So that is our slope, 5/6. And if we wanted to calculate it on our calculator in a decimal, that would also equal 0.83 repeating. Okay, 5/6 is a good answer. You could leave it like that, or you could write it in a decimal. Depends on how they want it. Usually they want you to keep it in a fraction. But 0.833333, what does that mean? Well, you can really put any number over 1, so it means you rise up 0.83 every time you run once. Okay, so you run once, you go up 0.83. Okay, and then from there, if you went over once again, you'd go up 0.83 from there again, and so on. Okay, So that's what slope means. So let's do some examples. All these are linear lines. If we remember, what is a linear line? It just means it's a straight line from 2 points, or a straight line in general, where the slope is the same throughout. So it doesn't change, it's just the same straightness, and it doesn't change throughout. So out of this linear line, what's our slope? Okay, so here we have to determine the slope. We know it's rise over run. What's our rise? We have to determine that. So from our first point to our secondmost point, you have to know your rise. So one thing to note is you could say this is your first point and you're going to your second point, and you would still get the same answer. Okay, you just have to make sure your signs would be correct. But I generally always go leftmost point to rightmost point. That's how I do it. So my rise from my left to the right, if I draw like a nice triangle here, it has to be a right triangle. I can go up 1, 2, 3, 4, 5, 6. So my rise is positive 6 because I went up. And to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 over 10. So what does that mean? It means the slope of this line is whenever you go up 6, you must go over 10. Okay? But we know this fraction. We know we can simplify it. So it's really the same as 3 over 5 because you can divide the top and the bottom by 2. And this is the simplest fraction. So what does this mean? It means you can go, when you go up 3, you have to go over 5. So let's try that. We go up 1, 2, 3, and then over 5. 1, 2, 3, 4, 5. And we end up back on the line again. So you can see that both these are different representations of our slope. They're both right. Okay? We can also type that in our calculator, 3 divided by 5, and we get 0.6. That is another representation. What does that mean? We can put that over 1 if we wanted, and it would mean we rise up 0.6 every time we move over once. Okay, so if I move over once, I go up 0.6. So that would work as well. So there's an infinite amount of ways you could represent slope, but this is how you calculate it. You go rise over run. Now B, we have another slope here. From C to D is how I would do it. Again, from D to C should get you the same exact answer. But here I always go left to right. So C is more left than D. So I'm going to start with C as my first point and D as my second point. Slope is rise over run. And then this is equal to, let's see, we go down 1, 2, well, we got to draw a triangle first. And it has to be a right triangle. And now we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my rise is 10. But wait, we went down, not up. So that's an important part. We went down, so it has to be a negative 10. Okay? And then our run has to go over from here, from our C spot, over 1, 2, 3, 4, 5. So was that to the right or to the left? We went to the right from our first point. So that's going to be a positive 5, so we're right there. So that's our slope, negative 10 over 5. So every time we move over 5, we go down 10, and that would make our slope. You would note that every negative slope kind of goes downward like this. Every positive slope kind of goes upward like this. Okay? So we can simplify this though. Negative 10 over 5 is the same thing as negative 2. And negative 2 we can put into a fraction if we put a 1 on the bottom. So it's the slope is negative 2. That's what it is. It means that every time you go over 1, you go down 2. So let's see. If we go over 1, we go down 1, 2, and we back on the line. So it works out. It checks out. Okay. Now let's try C. Okay, so for this example, I told you that the other way would work as well. I always like to go, that's my first point, that's my second point. Leftmost point is always my first one. Secondmost point is always my second one. Okay, but in this example, I'll say this one's my first and this one's my second. So I'm going to do it backwards just to show you that you can do it. Okay, so I'm going to say F is my first one, E is my second one. Let's draw our triangle. So from F to E, I go straight over and straight down I make my right triangle. Okay, now let's go F to E. So slope is rise over run. My rise, let's see, from F to E is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I go down 9. So my rise is -9. Okay, I probably should have used my triangle. That would have made more sense. I went over there. And now we want to go F to E in the X direction. We go F to E is 1, 2, 3, 4, 5, 6. So we go 6 to the left. Okay, so notice I'm going to the left here. And left, if we remember, always means negative if you're going to the left. So I'm going to the left, so it's going to be -6. Okay, so now I have -9 over -6. We know we can simplify this, so let's do that. 9 over 6, and we know we can simplify that because a negative divided by a negative is a positive. That's how we got that. And now what number goes into both a 9 and a 6? A 3. 3 goes into a 9 3 times, and a 3 goes into a 6 2 times. So overall, our slope, all these three are right, but generally you never represent something as a double negative. You'll just switch it to the positive version. So our slope is 9 over 6, or 3 over 2. Or that means that we go up 9 and over to the right 6. So we go up 9 over to the right 6. Or it's the same as up 3 when you go over 2. Up 1, 2, 3, you go over 1, 2. And that's back on the line. So it represents a slope as well. Okay, so you see that it works if you choose either one first. You just have to be really careful about the signs, okay, that they're both right. But let's go back to the left point being our first one and the right point being our second one. That's generally how I like to do it. So rise over run is our slope. Our rise here, let's draw our triangle. We go down 3, and it looks like over 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so our rise was down 3, and then our run was to the right 9. Okay, so now that, if we simplify it, is now -1 over 3, because 3 goes into 3 once, and 3 goes into 9 3 times. So our slope, our simplified version of the slope, is -1 over 3, which means every time you go over 3 units, you go down 1. Okay, every time you go over 1, 2, 3 units, you go down 1. Checks out. Okay, or the same as every time you go over 9 units, you go down 3. So if we went over 9, we'd go down 3, and that would work out as well. Alright, so now let's work on to the next one. Determine the slopes of the given lines. These ones are special ones. So if we look at this, let's do our normal slope calculation, rise over run. And if we look our rise from one point to the other, which point do I choose as my first and which one do I choose as my second? They're both on the same x unit. So I'll just say the top one's my first one and the bottom one's my second one. So how much do we rise? Well, we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We go down -10 units. What's our run? Well, I'm not really moving anywhere. I'm just going straight down. So our run is 0. Okay. So our slope is -10 over 0. So how do you divide 10 things between 0 people? It doesn't make any sense. So here, this division, if you typed it into your calculator, would say error. So a special thing when you have a 0 on the bottom, it's called undefined because it's impossible to divide anything into 0 people, okay? Because it doesn't really make sense when you say it at all. So this is called undefined. So the slope of a vertical line is undefined, okay? Because we don't know how much it's increasing for every run of 1, okay? Because it's just kind of going straight up. So a vertical line, a straight up or down line, has an undefined slope. That's one thing you can either memorize or you can do the same process I did to come up with the conclusion that it's undefined. You can never have a 0 on the bottom of a fraction. Next one, slope rise over run. Here, your rise from point 1 to point 2, we can tell is 0. We're not going up any, and we're not going down any, so it's going to be 0. And our run is going to be 1, 2, 3, 4, 5, 6, 7, 8. We're going to run 8. So overall, our slope is 0 over 8, or really 0. 0 over 8 is the same as 0. So one thing to note here is any horizontal line, or a straight line that's completely sideways like this, has a slope of 0, which means it does not increase in the y direction for any movement in the x direction. It stays on the same y value. Alright, so let's try example 3. Draw a line segment starting at the given point with each given slope. Okay, so this one's a bit different. They give us the slope, we don't have to find it, and they give us a point. So they want us to draw the line segment now. I'm just going to grab a ruler for this one. If you don't have a ruler, you can always just use the side of a book. That works as well. So -2, -3. We should all know how to find that. 1, 2 to the left, down 1, 2, 3. So I'm going to draw my circle right there. And then our slope is 7 over 5. So that means I'm going to, let's see what slope is again. We know it's rise over run, so that means I rise plus 7 and I run plus 5. Okay, so that means I go up 1, 2, 3, 4, 5, 6, 7, and I run 5 from that spot. 1, 2, 3, 4, 5. I'm going to put another dot there because I know it's going to be on the line. So once you have two points on any line, you know exactly what every point of the line is going to be. And how do you do that? You line up a ruler and you draw a line. So 2 points define any line in a plane. Okay. Make it nice and neat. Alright. So that's my line there. I drew it through the 2 points. And overall, that is the line, and that's what we had to draw. Okay. Now here's another line. We want to find when a point is -4, +3, and our slope is -3, 8. How we write this is, if you ever have a negative, what I always do is bring it up with the top one. So it's the same as -3 over 8. And we know this is rise over run. And so our rise is down 3, and our run is +8. 3, 6, 8. So another point there. And then we can draw our line. So there we go. Now we drew the line for that information. So now let's go to our last page here. So we found out that slope is rise over run, and our slope is y2 minus y1 equals x2 minus x1. So determine the slope of the line that passes through -5, -3. Okay? So one thing they wrote here is an equation that is the same as this. This is stuff that we've kind of been doing already, but it's the change in your y. It's your second. This 2 means the second point. This 2 means part of the second point. This 1 means part of the first point. This 1 means part of the first point. So what we're going to do here is see an example and see how we can use this. But you can calculate the slope of any line if you are given 2 points. One point is called x1, y1, and then another point is called x2, y2. Okay, so given 2 points, any 2 points, you can find out the slope by just plugging it in this equation. Okay, so here's an example. Say there's a point, -5, -3. If I drew this really quickly on a graph, it would be -5, -3 around there, and D would be 2, 1, 1, 2, and up 1. Okay, so something like that. So if you had a line like this here, you have to find the slope of the line. So it's y2 minus y1 over x2 minus x1. So y2, this is our D point, this is our C point, our y2 is here, and our x2 is here. Our x1 is here, and our y1 is here. So our slope here is y2 minus y1 over x2 minus x1. And so our y2, if we look, is our second point. It's the y value of our second point, which is 1. Our y1 value is the y value of the c value, which is negative 3. Our x value of the second point is 2. And then we subtract the x value of the first point, which is negative 5. See how I always put the points in brackets? That's an important part because you have to know if you have double negatives or not. So we have two double negatives here, so we can go double negative makes a positive, double negative makes a positive, and this will make a 1 plus 3, which is 4, and a 2 plus a 5, which is 7. So this is an equation to go straight from 2 points to the slope of the line without even drawing the line. I drew it just so that we could kind of see. So what does it mean? It means we have to go up 4 and over 7 units for this line. Okay, and that's the simplest version of this slope that we can get. Okay. All right. So example 5. This is the last example. Yvonne recorded the distances she traveled at certain times since she began her cycling trip along the Trans-Canada Trail in Manitoba from North Winnipeg to Grand Beach. She plotted these data on the grid. Okay, so now I'm going to look at the grid. Graph of a bicycle ride. So I look at my axes. The y says distance in kilometers and time in hours. So this looks like when she traveled. For 1 hour, she went 24 kilometers. When she traveled for 2 hours, she went for 48 kilometers. When she traveled for 3 hours, she reached 72 kilometers away. Okay, so it's saying what is the slope of the line through these points? So I got to draw a line through these points. So I start at 0, 0 because I know that the distance she traveled at time 0 was 0. So I draw a line as well as I can through all those points. What is the slope of the line through these points? It's asking. So we know slope is equal to rise over run. There's two different ways I could answer this, so I just need to know. Let's say I choose this as one of my point, and this is my other point. You could choose any two. How much do I rise? 1, 2, 3, 4. So my rise would be positive 4. And my run would be 1, 2. To the right 2. So it would be 4 over 2, and let's simplify that, and that equals 2. Okay? So our slope is 2. Okay? And what does the slope represent? This is important, especially if you go into physics. You'll be using this a lot. What does the slope represent? Well, the slope, you have to know what units it represents. So it's really the y divided by the x. So if we choose the units, it's the kilometers divided by the hours. So what does it represent? 2 kilometers per hour. Where if we put the 1 on the bottom, it would be 2 kilometers for every 1 hour that the person bikes. But the one thing I made a mistake on is my rise. I made a mistake on because I said we went up 4 units. We went up 4 boxes. That was correct, but I did not look at the units on the left, and that was a problem. So let's fix that right now. Our run is not quite right either. Alright, so let's try this again. Our rise, we go up 24 units instead of the 1, 2, 3, 4. Because a box doesn't mean 1 kilometer. So that was my mistake. So we go up 24. And then the run, we go over 1, 2. 2 boxes, but it means 1 hour, they're saying. So it's really 24 over 1 is our slope. And what does that simplify over? 24. So what that really means is the slope is means this person's going 24 kilometers every 1 hour. Or it just means 24 kilometers per hour. So the slope represents speed. So this is distance over time, and the slope tells you what speed the person's going. Okay? All right. Last one here. How can the answer to part B be used to determine how far Yvonne traveled in 1.34 hours? Okay, 1.31 3/4 of an hour. Okay, so here we can make an equation. We know equation of a linear line. We'll learn this next class is generally the slope the slope here is 24 is 24 times x, and that's our linear line there. Okay, so here what this is telling us is we can go the slope, or the speed the person's going, times the time that they're going, and that will give us how far they traveled. So if I go y, which means distance traveled, equals 24 times 1.75, because 1.75 means 1 3/4. We type this in our calculator and we get 24 times 1.75, oops, and we get 42. So that means our y value means the unit kilometers, so my answer is 42 kilometers in 1.75 hours. So this is a good way in how to use a linear equation. All right. And now it's saying the time it took Yvonne to travel 55 kilometers. So this time they give us the kilometers and they want us to know the time value. So we can use the same equation here, which is y equals 24x. And then our y value is 55 this time, not our x value. And we have to find out the x value. So let's solve for our x. So we have to divide by 24 to both sides. And we end up getting an x is equal to 55 divided by 24. And that gives me 2.29, roughly. So what does that mean? What unit should it get? It's an x. X is time in hours, so it's 2.29 hours. All right, so overall, if you traveled 55 kilometers, that means she traveled for 2.29 hours. And you could use this equation over and over again to find any time or any kilometer value. All right. So these are the practice questions. Try them out, and please ask if you have any questions. And one thing I wanted to mention is if you have, this is a new lesson, but we don't have to cover this lesson. I just wanted to go over what parallel kind of means. Perpendicular as well, but mainly just parallel. Okay, so parallel lines have the same slopes. So an example here is if you have two lines that look exactly the same slope or have the same slope, then you can call them this term parallel. Okay, so if you calculate two different lines' slope and they're the same slope, we can call them parallel lines. Okay. The last part with this, which is really complicated, but you might see in the future, is perpendicular lines have slopes that are called negative reciprocal. And so we're not really going to cover this, but I just wanted you to know that is if you take two lines, say a line here and a line here, and you calculate their slopes separately, So you calculate this slope, and then you calculate this slope, and you look at the two numbers. If one, say this one is slope of 3, then a perpendicular line like this one would be negative 1 over 3. Okay, that's an example of a negative reciprocal. What does it mean? It means you take the number, which is 3 over 1, and you flip it, and you put a negative sign. It's a fancy word, negative reciprocal. Another example is if you have a slope of 1 over 8, and you want to go negative reciprocal, it's negative sign, and then you flip it, 8 over 1. Okay, so whenever you see two slopes that have opposite slopes, kind of like that, not really opposite, they're called negative reciprocals. That means they're perpendicular. And you can see a little right angle square there. And what that means is they're perpendicular. They're perfectly perpendicular, or they go at right angles to one another. Okay? All right. I just wanted to make sure I mentioned that. Thank you.